Today we're going to look at factoring with a lead coefficient. This is 6-3 in your book. This is where we have a trinomial where the quadratic x squared has a coefficient greater than 1. Alright, so when I multiply 2x plus 3 times the quantity of x plus 5, I do my double distributing. 2x times x makes 2x squared. 2x times 5 makes 10x. 3x, 3 times x makes 3x, added to the 10x makes 13x, and 3 times 5 makes that 15. So what we're going to do today is figure out how to take the trinomial and work it backward to the two binomials that multiply into it. So let's start with 3x squared plus 8x plus 4. When I'm working with a quadratic like this, the first thing we're going to do is make our x marks a spot. But I'm going to multiply my lead coefficient 3 and my 4, and what I get is a 12. Now that is the product that I'm going to be looking for, a positive 12. And then I'm going to take my middle term, the coefficient, positive 8, and basically what I'm going to be doing here is breaking that 8x term apart into two terms. So what multiplies to positive 12 and is a sum or difference to 8? The numbers would be a 6 and a 2. So what I'm basically going to do is I'm going to use my first coefficient, 3x squared. I'm going to use the last term, 4. And then I'm going to break up that middle coefficient, 8x, into two parts, plus 6x and plus 2x. So all I've really done is broken 8x into two parts, utilizing that 6 and that 2, knowing that 6x and 2x really make up the 8x. Now I'm going to factor by grouping. In the first binomial, I can divide out a 3x, and then I'm left with x plus 2. And in the second binomial, I can divide out a let's see, it's a positive 2. And I'm left with 2x plus, I'm left with x plus 2. If I divide out my common binomial factor of x plus 2, right there and there, I will be left with 3x plus 2. Now we can double check, make sure that we end up with 3x squared plus 8x plus 4. So x times 3x makes our 3x squared. 2 times 2 makes our 4. And now really what I'm looking at is I get 6x and I get 2x all together. That makes 8x. That's my middle term. So the answer to this question is x plus 2 times the quantity of 3x plus 2. Take a minute, write the notes if you need to, and pause the video because we're going to move on. Alright, now let's try it again. I'm going to put my x marks a spot this time on this side. And I'm going to work on my number 1. So I'm looking for, remember, I have to multiply the lead coefficient and I get negative 12, and my middle coefficient is negative 11. So I'm looking for two numbers that multiply to negative 12 and add to negative 11. So the first one would be, how about negative 12 and positive 1? Yep, that works. So now I multiply I'm using the first term, 3x squared. I'm using the last term, negative 4. And then the middle term, remember, I'm breaking down by plus x and minus 12x. Okay, I'm going to factor by grouping. And in the first one, I'm going to divide out an x, and I'm left with 3x plus 1. Now the second one, I'm going to divide out, how about a 4 plus 4? Now when I divide negative 12x by 4, I get negative 3x. When I divide this by positive 4, I get negative 1. Now what's happening is that's the opposite of what I want. Both terms are exactly opposite. So let's go back for a minute, and I'm going to redo that. Instead of dividing out a positive, I'm going to divide out a negative 4. Sorry, I can't get that. All right, negative 12x divided by negative 4 makes a positive 3x. And then negative 4 divided by negative 4 makes a positive 1. So there we go. My binomials are the same. I can divide them out. 3x plus 1. And what's left is my x minus 4. I'm going to double check. 3x times x makes my 3x squared. 1 times negative 4 makes my negative 4. Now I just do a quick little check on my inner is positive 1x. My outer is negative 12x. Altogether, that does make negative 11x. Pause the recording and write the notes if you need to, as we're going to move on. All right, so now I'm going to let's move on to the next one. Take a minute. What do you think you'd do first? That's right. You multiply the first and the last coefficient of 2 times 10, and that becomes 20. And it's positive 20. And I need to know what adds to negative 9. Why don't you stop the recording and see if you can do this one on your own. Now check your work. So we said it multiplies to 20 and adds to negative 9. So if I do that, I'm going to, let's see what numbers. I'm going to say negative 4 and negative 5. So I start with my first term. Remember, it's 2x squared. Actually, let me erase that and move it up a little. I'm going to change this to in black. New color. All right. So I'm starting with my first term, 2x squared. I'm going to use my last term, 10. And my middle terms are going to be made up of negative 4x and negative 5x. Okay, factor by grouping. I'm going to divide out a 2x. And what I'm left with is left with an x. And here I'm left with minus 2. The next one, I'm going to divide out a negative 5. And I'm left with x minus 2. So if I divide my common factor binomial out, I'm left with x minus 2. I divide out x minus 2, and I am left with 2x minus 5. Double check. X times 2x makes 2x squared. Negative 2 times negative 5 makes positive 10. I have negative 4x. I have negative 5x. That makes negative 9x. All right. Now try the next two. See if you can come up with the answer. Pause the recording and work on the next two problems. Check your work now. For number 3, the answer is the quantity of 2x plus 5 times the quantity of x minus 6. For number 4, the answer is 2x, the quantity of 2x minus 3. I know you can't see that, so I'll rewrite it, times the quantity of 3x minus 4. All right, now I'm going to skip ahead a little bit. You can always go back, pause the recording, and see if you can work out these problems. All right, so in real factoring, what happens is everything's kind of mixed together. It's been very nicely laid out for you guys so that, on one day you're just doing difference of squares and just factoring out perfect square trinomials or factoring things without a lead coefficient. And so in reality, you're going to get something that might look like this. Remember, the first step in all factoring is to always check for GCF. So right away, I'm going to divide out a 2x. I'm now left with 3x squared minus 13x minus 10. At this point, I'm going to do my x marks the spot for the 3x and multiply the 3 times the negative 10, which makes negative 30, and what adds to negative 13. See if you can come up with two numbers. Now, I had a lot of people today. They tried 10 and 3, but does negative 10 and negative 3 does add up to negative 13, but it doesn't multiply up to 30. So those are actually the wrong answers. It ends up being negative 15 and positive 2. So remember, I'm going to start with, I'll keep this highlighted in the same color, the GCF as 2, okay, as what I'm circling 2x. I've got my 2x, and then I have to start with my lead coefficient, 3x squared. And of course, we've got our negative 10. And then I'm breaking up my negative 13 by a positive 2x and a negative 15. So it doesn't really matter where I place it, but I'll just do positive 2x and negative 15x. I'm going to factor by grouping. And now I can divide out of the first binomial an x term. And so what I am left with is 3x plus 2. And in the second one, I'm going to divide out a negative 5. And what I'm left with is 3x plus 2. So I divide my binomial factor out, 3x plus 2. What's left is the x minus 5, and don't forget what we started with, our GCF. All three of those are what you need to factor out 6x cubed minus 21x squared minus 20x. Pause it, take your notes, and now let's move on. Now in something like this, make sure you got your, just remember, every time we're doing this, there may be a different kind of situation that arises. So is there a GCF? No. So I'm going to do my X marks the spot. Start with, oops. What multiplies to positive 16 and adds to negative 17? I get negative 17 and, nope, negative, sorry, whoops, negative 16 and a negative 1. So remember, we're going to use the first term, 4x to the fourth, and I've got my last term, the 4, and the 17x I'm going to break up by minus x, and how about a minus 16? Minus, oops. I think I'm going to turn that around. I think I want to move it. No, that's okay. Okay, now, as I divide my GCF out, I know I can divide, oh, be careful here. Here's the mistake I made earlier. So, now remember, what's left here is a 17x squared. So it's not just going to be an x, it's negative x squared and negative 16x squared. Okay, so if I divide out my GCF out of the first binomial, what I'm left with is, I'm going to divide out an x squared. And what I'm left with is 4x squared minus 1. Then I divide out a negative 4. And what I'm left with is 4x squared minus 1. Okay. So now really what I'm left with here is x squared minus 4. That's what's left. Well, let me erase that. How about let's color code this. Well, it doesn't matter. Okay, my binomial factor is 4x squared minus 1 times the quantity of x squared minus that negative 4, or minus 4. All right, are we done? Looks like it, but guess what? We're not. We're not, because we are left with, actually I'm left with x squared minus 4. I'm left with two differences of squares, a perfect square minus a perfect square. A perfect square minus a perfect square. So the first one breaks down to 2x plus 1 times the quantity of 2x minus 1, and the second difference of squares breaks down to x plus 2 times the quantity of x minus 2. And this entire amount is the complete factored form for 4x to the fourth minus 17x squared plus 4. Take a minute, write the notes, as I'm going to erase it. Pause the recording if you need it to stop. So let me reiterate. I factor using grouping, and my x marks the spot. When I'm left with a difference of squares, remember, you have to break it down. All right, that's it for 6-3.